Hi everyone, it is Mr. Youngren once again. Just take my mask off here. And we are going to continue our work with logs. This time we're going to work backwards and instead of uh, using those properties to spread out the logs or create more logs, we're going to now take a bunch of them and condense them. But before we do that, we do have an opener. I will say that the opener is not easy. That doesn't mean you can't do it. I still want you to try. Think about some of the things that you can do. For example, I see a lot of things going on here. Can they be factored? Do I even need to factor? Is there another way to go? Okay, there's going to be a lot of different ways to kind of figure out how to uh, multiply all these out, okay, or how to expand these, I guess is what I should be saying. So why don't you hit pause, work through these. I'll have somewhat of an example when you come back. But like I said, they are challenging and I don't want this video to spend too much time on that. But either way, let's go ahead and give it an attempt and we'll see how it goes once you hit on pause. So pause right now. All right, well, here is what you should have gotten. And I'm just gonna say a couple things because it was a mess. Like I said, it was challenging, but the challenging part is the fact that some of these things are factorable. That's one thing that a really important skill that we've worked on this entire semester is being able to look at polynomials, even when they're in logs, and being able to factor those. So over here, I'm like, hey, I can factor y squared minus 9y plus 20. I didn't do it until after I split it up, but that factors to y minus 5, y minus 4. So the first thing I'm like, well, I see division and I know that division is friends or leads to subtraction. I'm gonna take the top, whatever those logs are, and divide it or subtract it from the logs on the bottom. But kind of keeping all the things separate, right? So y to the eighth and y minus 1 to the fourth separate from each other. And then those are going to turn into adding, and then I'm subtracting all those things on the bottom. Now remember, anything that comes after a subtraction sign, we want to put parentheses because of that, the ordering mattering there. So this whole thing is going to stay in as big set of parentheses even after I continue to expand them. But that's about all that I'm going to say there, because the last step for me is taking any exponents, making the coefficients, and then just splitting up the two factors here into two logs that are then being added, but overall still being subtracted. So yes, it's messy. Can you do it? Absolutely, but you got to try. The next one, I started off, I'm just like, okay, I see this polynomial. I noticed that they have a GCF of x cubed, pulled away that x cubed, and what was left over is x squared plus 11x plus 18, which can be factored to x plus 9 and x plus 2. So I have three things being multiplied with a coefficient of 5, so I can pull that coefficient to be in front of the natural log. And then since I have these things being multiplied, we can write three new logs where they're all being added. And each one of these terms is with each log. So x cubed, x plus 9, and x plus 2. The last thing is that since I had another exponent, I needed to bring that back to the coefficient. I'm actually going to multiply those two numbers to get 15 natural log of x, then 5 natural log of x plus 9, and 5 natural log of x plus 2. If you look at this and you go, I cannot figure that out, I'm looking at your work, I've spent 15 minutes trying to figure out, I still can't do it, you're going to be okay. These are tricky, but still, just because they're tricky doesn't mean we can't do them, doesn't mean we don't want you to try them. So don't feel discouraged if you're like, I have no idea. Hey, we want to still practice them and know that we're still working on these skills. So don't beat yourself up if you're not quite there yet. All right, well, today's lesson actually is going to be really quick. This video will be really quick because we're doing the same thing as last time, but now we're just going in the reverse order. So just a reminder, here are all our rules. Again, the names don't matter. You want to pay attention to more as to what do those rules look like. So if we're adding two logs, we can bring them together and multiply the two things that we're taking the log of. If we're subtracting, they can be division, and then that coefficient becoming the exponent. So our task here is going to be for us to condense these logs so that they are just a single log. And we'll go ahead and work through all four. And that way in class, you can pick up for the group practice. So I'm looking at this, I'm like, okay, one, the bases need to be the same. And in almost all these cases, they are. So logs, the bases are the same. I see that I'm adding these two things, which means I can condense them where the base will stay the same. And I'll multiply the two things of what I'm taking the log up. Now, if it's obvious as to what's being multiplied can be simplified, let's do that, right? Like 2 times 8, we know is 16. And there we go. Okay, there is the condensed log. Much more simple than that expanded log. Some of you might ask, what's the point even expanding it? It does have value when we start solving. So know that it's just a skill we'll use later on. Okay, moving along. Next one, the first thing I see here is this 2 out in front. And so I actually want to bring that to be my exponent first. So it's minus the natural log of x to the power of 2. So it's really an x squared. And since I'm subtracting, we want to divide. Now remember that the order matters here. So whatever we're subtracting from, so this natural log of 4x minus 3 needs to be the numerator of the top of my fraction. So it's natural log of 4x minus 3 over x squared. So just taking the top part of what, or the first part of what we're subtracting divided by the second part. And there's my natural log. All right, moving along. Now we have 3 logs. A little more complicated, but still we can handle it. So once again, we kind of always want to take care of the coefficients becoming the exponents first. Some of you probably don't need to rewrite it. With me, I like to write every single thing. That way, if I do make a mistake, I can kind of go back and look at where that happened. It also helps me just organize my thoughts. So I have 3 different things being multiplied, which means, or 3 different things being added, which means we can multiply all those things together. So this is really the log. Remember, if we don't write a base, it is really base 10 of x squared times x minus 2 times x plus 2. And you know what? Since we know how to do it, let's multiply all these things. So I can do, I'm going to leave the x squared, but x minus 2 and x plus 2. Some of you might need a box to do that. It's really foiling, but I don't like that word foiling because it doesn't always apply. But anyways, this works out to be x minus 2 times x plus 2 gives me x squared minus 4, which I can then distribute the x squared into all of those terms to give me x to the 4th minus 4x squared. And there is the simplified log. So, right, even if you got here, that's perfectly okay. But if we can look to simplify what we're taking the log of, that's always nice for us to do. So getting here is something that we want to encourage you to do. All right, and then the last one, something that you're going to see, you should have seen it back when you were expanding logs, but when we're condensing, if I have a fraction here, one thing that we need to remember, I guess maybe we haven't learned this yet, but if I have x to the power of 1/2, that is equivalent to the square root of x. Similarly, if I have x to the power of 1/3, that's the same thing as the cube root of x. This is going to be important when we're actually trying to simplify, and it applies here because when I go ahead and make that my coefficient, log base 5 of x plus 2 to the power of 1/2, and I'll just go ahead and take care of the other exponents here, log base 5 of x minus 1 to the power of 4 plus log base 5 of x to the power of 3. Anything to the power of 1/2, we are actually taking the square root of all that. So this is really log base 5 of the square root of x plus 2. And then the other ones will stay the same. And I'll do the condensing here in just a second. So plus log base 5 of x cubed. So I see that all these things are being added. So I can go ahead and multiply them all together to give us a condensed log of the square root of x plus 2, which is being multiplied by x minus 1 to the power of 4 by x cubed. And you can multiply all that out. That would be a stinking mess. So let's just call that good. X minus 1 to the power of 4. That'd be a big box in order to get that. But that's really all that we need. All right, that's it for this video. You now have lots of practice that follows. And if you have questions, make sure you ask your corresponding teacher and make sure you complete your video check-in and have a great rest of your day.